we're finishing up, like I said, is today we'll be finishing up, or by Thursday we'll be finishing up and reviewing anything in chapter 2. So this right here, there's just a couple of things in it that we're concerned about. As I had said last time, 097 and the first part of this class has a good bit of overlap. So what we're just trying to do is refresh your memory on things like slope and parallel lines. So if it seems like I'm going fast, um, in a sense I am, but like I said, I'm trying to refresh your memory. And so if you have any questions, just let me know. So the first thing to remember is parallel lines all have the same slope. All right. Parallel lines have same slope. So if we wanted to um, write the equation of a parallel line that goes through um, the point -2, 5, and it's parallel to y is equal to 3x plus 1. And that, just notice that that thing is in what we call the slope intercept form, y is equal to mx plus b. And that at a glance tells us that the slope is 3. So the slope we're going to build with this equation here, I'm sorry, with this point here is 3. So we just put it in that form that we looked at that last time, which was the y minus y1 is equal to m times x minus y1. So you just pop it in there. And again, you got the equation, and there you got it. Now, they don't, one of the things I noticed about this textbook that's a little bit different, um, I don't think that that was specific about what form you put it in. In Math 097, we say put it in the slope intercept form or standard form. All right. So perpendicular lines have a slope whose product is -1. And what that essentially means is if you take the slope of a line and then its perpendicular line, multiply them, you will get a product of -1. All right, so let's kind of see what that means. All right, so we got this equation here. This is what this textbook calls the general form. So what we got to do is find the slope of it if we want to come up with a perpendicular line. So the slope, once we solve for this, is y is equal to -1/3 x plus 4. So the slope, the number, the value in front of the x is -1/3. Now I will tell you, as we kind of stated in 097, the better way to look at it is it's the opposite sign. So in this case, the slope is a -1/3. So the perpendicular line is going to have the opposite sign, which is positive. And then we take the slope of 1/3, which is 3/1 or 3. Okay. All right. And then they talk about rate of change, which is really what we almost ended with. It's simply the slope when you're talking about rate of change. So it says, no, we actually did that one, didn't we? Yeah, we actually did that. So we got through 2.4. I don't think we did this one, though. Let's do that one. So you can also do it with functional values. Remember, y is essentially the same thing as f of x. It's just that when you got f of x, you know you have a function rather than just a relation. So when you see that f of x there, all that's just saying is y. So then when you do that, they give you, well, in this case, they give you the function f of x is equal to x cubed, and then they give you two different x values. So in order to find out the numerator, remember that's the functional value or the y value. So you kind of have to put 0 in for 2x2, and then x cubed, I mean, x cubed gives you 0 cubed, which is 0. And then here again, we're just using the slope formula minus a minus 2 cubed. And minus 2 cubed is minus 8, and minus a minus 8 is positive 8 over 2 is 4. So again, we're just seeing it there. And again, this 2.4 and essentially all of 2.3 are essentially review, okay, from 097. This one right here is kind of an exception just because we're using the functional notation. All right, any questions? The next part definitely is brand new stuff. So if you got any questions about the slope and all that and equations. And really 2.5, there's almost no calculations to be done. It's just something kind of visual. All right, I was just trying to see who was here. All right, so let's go over this 2.5 thing. This is the main thing we wanted to look at today. And like I said, it's not really anything we can do in regard to calculations. What we're just going to do is just see how making certain changes on a function will transform it in a sense. So 2.5 is transformations of functions. So there's several different things that can happen. You can have vertical shift, you can have horizontal shifts, you can have reflections about the x-axis, you can use vertical stretching and shrinking, and then you can put them all together. Here's the most common type of functions that we'll be looking at. You've got a constant function, and that's why they have f of x is just equal to c. In other words, f of x is just equal to some number. That's just a straight line, horizontal line. F of x is equal to x. That's a linear function. All right. A linear function, a straight line. The f of x is equal to absolute value of x. That's that v. And then f of x is equal to x squared is the parabola. The the thing that goes down. It's in a way it's similar to the absolute value function, except it's got a turnaround rather than a point at the bottom. This is here is called the square root function, and then that's the inverse of the square or the parabola. And then the last two are also inverses of one another. That's the cubic function and the cube root function. All right. So let's just look at the common functions. We already kind of talked a little bit about domain and range. But if you got a straight line like this is a linear function, and they're just using the general term f of x is equal to x for a straight line, then both the domain and the range are all real numbers. And that's how we say negative infinity to infinity. And you'll see on this that it's increasing. In other words, it's going up all across the domain. It's what we call an odd function too, because x just has the power of 1. When we just have an x with no exponent, that's x to the first power, and that's an odd power, so it's an odd function. Here's the next one. This is the absolute value function. All right, the domain is still the same, negative infinity to infinity. All right. the range on it. In this case, it's going to come down to 0, touch, turn around, come back. So that's the range is 0 with the bracket going up to infinity. And it's decreasing as you come across here. It's going down. And then when you get to 0, it starts increasing. And it's an even function, actually. Here's the parabola, very similar to this one in all regards. You see the everything's pretty much the same. The only thing that's different is the actual function. This is the basic parabola. Notice how it starts decreasing at negative infinity and then gets to 0, and then that's when it reaches its vertex, and then it starts going back up, starts increasing. Now, um, also, the domain on this is all real numbers, negative infinity to infinity. It's an even function as well because it's got an even power. And then in this case, the range comes down to 0, and that's it. So here's its counterpart, the square root function. First of all, we might notice just at the bottom, it's neither an even or an odd function. And so the domain on this one is only going to have anything as low as 0, because if you know about the square root function, you put something negative in there, you got a problem. Now, maybe you remember from lower algebra that you can evaluate it as a complex number, but this is talking about plain real numbers here. So the domain can be as low as 0, but then can go up to infinity. The range is similar. And what it amounts to, see, it's only in that first quadrant. So that's what both of these mean. And it's increasing throughout, and it's neither an even nor an odd function. All right, the last pair, this is the cube root function. Notice kind of what it does is it, you can almost look at the parabola and having its arm bent down. And the reason why it exists below down there, below the 0 axis, the y-axis, is just because it can input negative values in there. We could put negative values in another one too, but in this case, it pumps out a negative value for every negative value you put in there because it's an odd number of negative signs, hence the function is odd. But it's the domain is all real numbers, as is the range. And it increases throughout. And then its counterpart, and you'll notice that it's very similar, it's just twisted. This is the cubic root function. And just as for the cube function, everything is the same. Domain and range, all real numbers. It's increasing throughout, and it's an odd function. All right, so let's talk about vertical shifts. All right, now this is just a general rule that applies to any function, especially the ones that we're just looking at, those 6. But if you add something to the function itself, not fiddling with the actual function, but if you just have like x squared plus or x squared minus, then what that does is shift this function. And what it does, depending on what that value is that's added or subtracted, they use C, the constant value. The plus pushes it upwards vertically, the negative pushes it down vertically. Let's see how that looks. All right. Here's vertical shift. So if we add 3 to the function absolute value of x, it's pulling it up 3 points. Now let's look at another one. Let me okay, let's just say we got x cubed. All right. So there's the x cubed function. So we can do one or two things to it. We can do plus 4, and then let's try it with a minus 4. or -2, let's say. All right. All three of those are the exact same shape. The only thing that's done to them is either shift upward, which is the red one, 4, or shifts downward, in this case, 2, because of the -2. All right, any questions? All right, let's look at the next shift then. All right, horizontal shift, which is back and forth on the x-axis. Now, what this essentially saying is, if we take the f of x function, and it could be any of the ones we're looking at, and then inside of the function put a plus or a minus, then it shifts on the x-axis. But here's the kicker, and this is why this is different. It's just the opposite as it was for the vertical shift. In other words, a plus c inside of the function makes it go to the negative side. It's sort of like how, no, y'all didn't do the circles. That's right. So anyway, and then the negative value added to the inside of the function shifts it to the right. What does that mean? Well, let's look. Here's a cube, I'm sorry, a square root function. A square root function. Notice that inside now the number is -4 inside of the square root function. So it shifts it 4 to the right, the opposite of what you might think. All right. So a shift or a negative value there, in this case 4, shifts it to the right, to the positive side 4. Let's look at some other ones. Let's go back to the old square root function. Now what you got to do is you got to put it inside. All right. So notice the green one is the square root. I'm sorry, the parabola formula, the x squared formula. All right. Also called a quadratic. The x minus 2 all squared. Notice what it does. It shifts it positive direction 2. All right. So the way you can think of it is x minus a minus in there, essentially. So if it's just x minus 2, like I said, the negative sign is built in there. So if it were x plus 2, then that would be going in the other direction. I'll show you what I'm talking about. All right. So plus 3 shifts it the opposite direction now. All right. See how it does that? Shifting horizontally. And it's the opposite sign of what is inside of the function. You can look at it as it's x minus whatever that number is. So in the case of x plus 3, it's x minus a minus 3. Gives us the negative shift. All right, now if we want to reflect, uh, did we go over the odd and the even? I confused this class with my other one. Anyway, we don't need to know it anyway. I was curious if I could use that term. But anyway, what reflection means is that if we have an x-axis reflection, then the negation of the entire function is going to flip it mirror image x-axis. And then if we put a value in where the incoming value for the function is negative, then it reflects on the y-axis. So here's the one on the y-axis. In other words, I'll show you in a second both of them. But notice they use the cubic function and they change it from x to negative x, so it reflects about the y-axis. All right, so let's go over here to the little where's my Desmos? There it is. Let's try something else. Let's try oh, all right, so there's the basic absolute value function. Now let's just say now I negate that, and that's the first one that they mentioned in this slide, which was right here. All right, I'm negating the whole function, so that's going to reflect it on the x-axis. So when I negate that whole thing, hold on a second. I'll tell you what, let me try the parabola. This one's a little bit different. Let's do the parabola. Okay, so x-axis shift. All right. So that one's right. I don't know what I was just thinking, but anyway, now let's look at the other one, the one we were just looking at, ABS, X. I'll try another one. I don't know I don't know if I'm using the right. Oh, this one's still under. Let's just try the X. Make it simpler. Sometimes something got in here and jimmy it. So that's the vertical shift. I'm sorry, the shift on the x-axis. I should probably take these off. Now let's say we got x cubed.
You said it's the shift on the x-axis, so it's not the reflection.
Well, that is a reflection, isn't it? It's just that
Yes,
your mirror
it's just
is
okay.
the x-axis. Okay. See that? So the negative sign on the outside of the function shifts on the x-axis. All right, so let me try something here. There we go. So let's now. So then there's the y-axis shift. All right. So the blue and the green are x-axis shift. And then if we want to shift on the y-axis, notice how it's mirror image. The blue and the red are mirror image because and it's along the y this time. That's because what causes that shift is inside the function changing from positive to negative. Okay. So that's the four shifts that we looked at. Then the other thing we can do is we can stretch this thing. There's two different stretching or compressing, we would call it. Um, if the value, and they call it C, and that just means the value in front of the function. In other words, if you got 3x cubed, then what that does is it stretches it out. And then if we want to shrink it, then what we do is we use a value that's a fraction, essentially, anywhere between 0 and 1, a fraction. Notice that it doesn't include 0 and 1. Let's look at those. Well, they got one for us. We'll look at theirs, and then we'll look at our own, because they're not giving us too much of a demonstration. So look at the red one. Notice how it's getting skinny because they've got a big number in front. And then the original one was the blue. All right. So that big number squeezes it in. So let's just look at it for a couple of different ones over here. All right, let's see what we can do. X squared, and then let's say 4x. See how it makes it a smaller one. And then if we have a fraction, I'll tell you what, let's put a 4. Then it makes it fatter. So the closer this thing right here in front of the x gets to 0, it's going to make it really, really, really big. And then the higher the number in front, essentially, it shrinks it. So that's what this calls stretching and shrinking. Because essentially what ends up happening is you're multiplying each one of the y coordinates by whatever that value is. In other words, whatever comes out of the functional value, you're multiplying it by that. See, in the case we just had a 4 there. So in other words, like for example, let's put some points on here. This one's a little bit harder to see. See, that one's on the function. And so if we multiply it by 4, so then we're multiplying the functional value, in other words, the y coordinate, by 4. And so it ends up essentially stretching it upward is what it's doing. Now with this one, watch what's happening. The original one was the green one. So let's say we take and we multiply by 1/4. So what it ends up doing is it puts it and pulls it outward, pulls the function value outward. In other words, it's pulling it out, making it smaller essentially as far as the y or functional value is concerned, but it looks stretched out fatter. All right, so now let's kind of just put these all together. So that's what we just looked at. All right, so let's just try and throw all these things in and see what happens. Put them all together. Well, we can look at this one, I guess, before we go. All right, so we got an x squared function, a quadratic, plain old x to the second power. It looks like the blue one, but if we put a vertical shift of -2, which brings it down 2, so we get to right here, and then this pushes it over in 1 to the left, so that's why it's over here, and then it's multiplying by that -1/2. I don't like the way this is set up, so let's do it on this little thing, and we'll do it with one function, and then we'll be able to see kind of everything. Let's just I'll do this one. All right. So let's say the first thing I'm going to do it is do that. That shifts it vertically. Now I'm going to also I'll tell you what, let's put just a whole number in front of it. Oops, no wonder. So see how that's making it smaller? All right. Now let's take that and shift it and do everything to it. Well, I'll tell you what, let's just go ahead and so I'm just showing you all the ones we looked at, and then we're going to put them all together. So there's all the ones that we looked at. But let's put it all together into one. So there's all together as one. Every one of the shifts that we looked at. It's turned it upside down. It's shifted along the vertical axis. I'm sorry, the horizontal axis, the x-axis. It's shifted up 2 and plus, I'm sorry, up 3. See, that's what moves up here. And then the -2 is going 2 in this direction. And then the -3 is shrinking it inwards and flipping it to where it's mirroring on the x-axis. So that's all of the shifts put together into one that we've seen in this section. All right, so that's pretty much it for that 2.5. There's nothing really to do calculation wise. It's just what does that shift mean? So as I had said is today's that. So then what we'll do is we can start reviewing today, but Thursday we'll review and then we'll have test 2 open. It's probably already open because I had so many of them to change that I just opened them up all immediately. So that because some people were asking me about going faster. So anybody got any questions? Let me make sure got everybody here. And did Savannah come in? Danielle come
I'm
in? Brent?
here. I'm
Okay,
here.
that was Danielle.
Yes.
Okay, good. Taylor. I didn't see Taylor, and that's all I got. All right. Well, I'm glad y'all are all showing up. That's good. All right. So anything you want to ask or do, that's what we use the rest of the class for. We got another half hour. So shoot. And I got the schedule here, and like I said, I just realized it was messed up. And what it is that the my math lab course didn't quite match the syllabus. So we're not doing too bad in time. We just got to kind of get in 2 more sections before the test 3/midterm. And then the midterm is like in 2 weeks, within 2 weeks. We already kind of missed the original midterm. We're going to miss the original midterm week. The original midterm week would have been like this week. So So we're like shifting a week in about a week and a half. So that's why we're talking about 2 weeks. I guess 2 weeks is about right. So we got plenty of time. So if you got any questions, just shoot. Because I'd like to know where y'all are at as far as material. Let me go ahead and fix this thing while I'm thinking about it. So this should go up here. So the third test is the midterm. So that's kind of what we're looking at right there. Like I said, I don't know why I didn't notice that this thing was messed up. Wait a second, wait a second. It's 5 and 7. There we go. 5 and 7, 12 and 14. There we go. All right, come on. Everybody got anything? I'll come up with something for us to do if we don't, but I'll just kind of go back and try to wake up your brain. I think whoever was looking at this was looking at it's September when they did this. Like I said, it's all right. So y'all doing all right? Everybody getting their lives back together? And I'll adjust these once I get that dates in. Well, what I'm going to do, I'm going to go back to that 2.4 and let's look at that in a little bit more detail. But anyway, keep an eye on this thing because it's going to be changing because, like I said, it was really messed up. But I'm going to have this pretty accurate before. All right. So we only go over like 4 chapters is the good news. All right, so that's more or less accurate up until this time. So I think we got a little bit more time in here than I thought. All right, so let's go back over and just use this 2.4 as a guide and we'll work some problems there. I'll bring up the book and look in the homework and see what we can go over. I think this is already expired. So I have to. Right. So, in just in case you don't know it, I mean, if you just at this point in college life, I don't think there's any point to having a hard cover textbook unless you want it, because you got a textbook in here. You got all kinds of multimedia stuff, including the multimedia textbook. You can access it another way through chapter contents, but just for informational purposes, if you go to multimedia library, pick the chapter and the section, and then you can click any of these that you want. The only ones I know about are the videos, which you've already got assigned in there, and then the textbook and the PowerPoints. Those are the only three I want. I don't even know what some of these other things are, but if you want to try them and got the time, that's good. Then you hit find, and then it opens up the textbook to that very place. So we'll just kind of go back through 2.4 and get a little bit more detail. And like I said, it's technically, this is supposed to be review, but let's just kind of go through things, and then we'll make sure you know about this stuff. Let's go to the back and look at some problems. Actually, in the Math 097, I'm now going over slope and what they're talking about in here. So even if you had Math 097, it's been at the beginning of the semester you would have had this. So let's look at some things, and then we'll work some problems. Um, all right, so let's look at number 10 and 12. Let's go over to this little board. So this is actually from that other Math 097. All right, so what was I going to work? Let's see, find let's copy it and paste it in here. Oop, it didn't copy it. Sometimes there's things they don't want you to copy them. So let's just see, it might not let me do it. Nope, let's have to type it out. So the first one was through -1, 3. And then they have to give you a slope, or they're going to say parallel. And what did they give us? 3x minus 2y minus 5. All right, so for all of these where you want to write an equation, you're using this little thing here, and I'll write it out. Sometimes it'll say write, it could say build. And slope is So what I'm going to do, I'm going to put a little one here and a one there. All right. So what they mean by point is x1, y1, and then slope, of course, is m. And so if you've got those two things, then we can build this in. Now, we already had the point. All right. So what we don't have is a slope, but we've got a line. So let's take that line and find out what the slope is. So here's the point. I'm sorry, the line. We already got the point. So the first thing we want to do is solve for y to get the slope. All right. Should be equal to 0. So the first thing I'm going to do is I'm going to get rid of the things that we don't need, which we don't need the x term or the constant term. So let's do the constant term first. So I'm going to add it to both sides. And in math 097, this is the way that you usually would see these. Like I said, in this textbook, they use this one here and they call it the general form. In Math 097, they'll have it in this form and they call it the standard form. All right. So now we need to get rid of the 3x.
I thought it was 5.
Well, I'm using this up here. Oh, I see what you're saying. Yeah, thank you. Thank you. I just wrote 0 and I should have put equal. Yeah, thank you. You're right on. All right. So now it's minus 3x on both sides, which is going to give us, I'm going to go in this direction, negative 2y is equal to negative 3x plus 5. All right. Now we got to do one more thing. Yeah, thanks, Danielle. I was just not paying attention when I was talking. Anyway, one more step to solve for y, and that is divide both sides by all things by negative 2. And then that's going to give us, see if I can squeeze it in here, y is equal to negative over a negative gives us just a positive 3/2 x plus 5/2. All right. So the m here is equal to 3/2. So that means once we found out the slope of that line we want to be parallel to, then we're going to just use this little thing here. It's called a form. It can be solved for different things. So that's why they call it a form. It is a formula, but it can be taken on several different forms. So now we're going to just do y minus 3 is equal to 3/2 times x minus a minus 1 which is going to give us a positive 1 there. So that's going to be y minus 3 is equal to 3/2. 3/2. Oops, let me fix that. And now it becomes x plus 1. All right. So the next thing I'm going to do is multiply all of these things by 3/2 on the right. I'm going to distribute that 3/2. So that means y minus 3 is equal to 3/2. This is going to be a little bit of a messy one. And then 3/2 times 1 is just 3/2. All right. So now we got an equation, but we're going to try to go by what they're asking in the instructions, which was write it in point slope form and the general form, which means then we're going to have to do a little bit more work. And in this case, because that one was fractional, we're going to have to mess with that. So let me write that over here on the next um, board page. So it's 1 minus 3 is equal to 3/2 x plus 3/2. All right, now it's really just one fairly simple step to solving it for y. Because if we plus 3 and then plus 3 here, then these got to be put together essentially. So we got to have an LCD. If you don't know about this, then whenever you got a whole number, remember that's over 1. So what we're going to do is just multiply 3 times 2. And so 3 is 6/2. So in other words, if you have 3 whole pies, then you slice each one of them in half, you have 6/2. So then these got to be put together. So 3 and 6 is 9/2. All right. So this is what they asked for on this one. This is the point slope form. Okay. Point slope. All right. Now, the general form, they call it. Remember, that's was what this one was in. So what we got to do is we got to have all the terms on one side and no fractions. So the best way to eliminate fractions in an equation is to multiply everything by the LCD, which is 2, because you'll notice that the only 2 fractions we got have a 2 in the denominator. Okay, so everything getting multiplied by 2. 2 times y is 2y. All right, so remember 2 is 2/1. So that's going to cause these fractions to drop out because 2/2 is 1. So this is 2y is equal to 3x. And then here the 2's go away as well, plus 9. No more fractions. All right, now I'm going to just take the easy way. We could subtract the 3x and subtract the 9, and that would be fine. But if we just kind of just subtract 2y, we got them all on the same side. So this is going to be 3x minus 2y plus 9. And the 0 technically is over here, but if two things are equal, you can switch sides without any problem. So there we got, this is what they call the general form. This one's a little bit longer than I thought it would be. All right, so let's try another one with perpendicular. All right. So we got this one here. It says we want to do passing through 5 and -9 and perpendicular to the line whose equation is x plus 7y minus 12. You know what? I'm just going to go ahead and use this one. It'll save a little time. So I'm going to add another question. Now, perpendicular. And what was the point? 5, negative, negative 5, now we can do 9. All right. So remember, over here, the slope was 3/2. Remember? Slope is 3/2. All right. So what we got to do is, all right. I'm going to put this little line right here. And I'll just put PS for perpendicular slope. I want you to just see what I'm doing. So what I'm going to first of all do is take the opposite sign and then take the reciprocal. All right. That's technically not how most textbooks handle it, but what they usually say is this thing about that the product of the two slopes is -1. So let's just check that out. So if you multiply anything by its reciprocal, you're going to get 1. But in this case, since we're also talking about a perpendicular line, the slope is going to be the opposite sign and the reciprocal. So the way that I like to write it is like this. Perpendicular slope is equal to -2/3. So the simple way to do it is just take the reciprocal and the opposite line. So in this case, it was positive, so it becomes negative. You started out with a slope that was negative, you change the sign to positive, and then do the reciprocal. So let's just do this line real quick because I want to be able to finish this. So then this is y plus 9 is equal to -2/3 times x is 2/3 x. And then negative times negative is a positive. And remember, this is over 1, so it's 10 thirds. So just in case you're having trouble seeing that, they're both negative. So nothing's coming out side to side, so it's just going to be 10 thirds. All right. So that line right there is perpendicular. Now, what I'm going to do is I'm going to hurry up and get it done. So we got a minus 9 to get it in the slope intercept form. And then it's 10 thirds minus 9 over 1. So that's going to be 3 times 9 is 27. See if I can squeeze it in here. All right, so then that's going to be y is equal to negative 2/3 x minus 17 thirds. All right, so that's the slope intercept form. It's a little bit messy one, but that's what we're going to have to live with. Let me just show you real quickly because we got just a couple more minutes. So let's just say I got y is equal to 3x plus 5. All right. So any line with that same slope is going to be perpendicular. I'm sorry, parallel. But watch what happens if we change the slope to negative, because it's positive 1/3 on 3. And so it's going to be negative. And then we'll just say plus 1. Oh, got to have an X there. So see, there's the perpendicular. See these right here? That's a right angle on both of these. And it doesn't matter what. This is why there's a bunch of them. There's actually an infinite amount of them because they can go through any points. All right. So anybody got any questions? Um, Thursday we'll review on anything that we've got here in this remainder of chapter 2. We'd already looked at 2.1, I believe it was, in the last section. So now what we're doing is we're doing the rest of chapter 2. Hold on a second. Everything's yeah. So pretty much just chapter 2. That's what we're looking at. Technically, it doesn't do 2.1, but since math is cumulative, you're still going to be dealing with those things. All right. So if you got any questions, shoot. I think I got everybody. The only people I didn't see was Savannah and Taylor. Everybody else I got. So, and remember, I don't use these for grades. I just take them because the college wants me to turn in. Well, so just try to finish up these sections of 2. Bring in any questions you got. We'll try to look at that on Thursday, and then we'll talk about when we have the test open. I'll probably just open it up like um, Friday, Saturday, Sunday, and Monday kind of thing. So that way on 10.5, we can start working on 3.1. All right. Well, I'll see you later. Unless you got some questions, I'll be here for a bit.
I have a question, Mr. Cruz.
Shoot. Go ahead, Anisha. I'm here. Can you hear me?
I have a couple of assignments that I missed, and I was wondering if you could open them up for me.
Well, okay. If they're, you should, most of them I've designed to open throughout. So you should be able to click on them and as long as they, the blue link. All right.
Yeah, the assignment from yesterday that you posted, or the assignment that were due yesterday that you posted, it's not a blue link. It's not letting me click them.
All right. Let me see. Because there's a whole chance that they're not right because, like I said, is this thing was crazy. Let's see. Oh, I see the one that says 2 point. Yeah, okay. I see which one you're talking about. Hold on a second, see if I can fix this. Because what I had meant to do is put them that where you could work on them for several days after they were due. They
Okay.
weren't like that because some teachers, the teacher that made this up was not evidently a fan of that. So there might be some that I didn't get. So let me check. All right, so it was 2.3. Oh, I see what happened. It was a late submission thing. Okay. All right, so let's put 10:15 in there. So that's about midterm. All right, so yeah, whatever. I know what it was. She had all these things with no due dates and no. So that's really what it was. Let me. All right. So now you should be able to see those. I'm gonna have to go through and fix all of these because I was just noticing. Yeah, she doesn't have
Okay.
allow, but those should be done.
Okay. Thank you so
If
much,
you
Mr.
see, if you
Cruz.
see any more like that, let me know. Uh,
Okay.
one of the things I wasn't sure what you were saying, so I'm glad you brought up what it was because every time a test goes by, I have like students coming out of the woodwork that they missed it, and I'm not after the first one. I just not in a position to be able to do that because I got every time I have a test, I got like 10 students, you know.
Yeah.
So, but yeah, on the assignments because yeah, there should all be fixed.
Okay. Well, thank you, Mr. Cruz. You
All
have a
right,
good day.
bye. Yeah.